Hello, this is Domenico with Easynomics, and today we're going to look at natural monopoly and how we can connect this model to economies of scale as well as to positive production externalities. Natural monopoly is a monopoly within an industry in which the high infrastructural costs and other barriers to entry, the high barriers to entry, really is the fundamental factor that keeps competition out. And you pretty much have one dominant firm or the firm that is the industry that is the largest supplier that's able to meet the needs and wants of society through their ability to invest their supernormal profit in achieving economies of scale. And as they achieve that economies of scale, they're able to lower costs on average relative to any incoming competitor. And thus, it makes sense that that one firm is the provider as opposed to a new firm coming in with higher average total cost curves. In addition, we'll look at the reasoning behind allocative efficiency, where it makes sense that one firm is providing to society as it's more allocatively efficient and not leading to a waste of resources. What are examples of natural monopoly? It could be public utility companies, water service companies, and we're going to use that as our applied real-world example in this video, electricity companies, telecommunication companies. For water companies, for a firm to start providing water to a village or town or city, just imagine the high barriers to entry in terms of the costs that need to be spent by the firm in providing all the piping, putting all the piping into the ground, connecting all that piping to every home, every building, every commercial space, every stadium. All of that money spent just to provide the water piping is an initial startup cost that really serves as a high barrier to entry. And before you even make revenue, you have to spend to provide all of that water piping before households start to pay or pay a fee for the water that you're providing. So the high barriers to entry is really emanating from, again, the high infrastructural cost that really keeps competition out. So the water industry, as an example, provides, hopefully, if it's done well, clean drinking water, and also manages the wastewater. And so these two elements of providing clean drinking water to society and also managing the wastewater coming out of households is a spillover benefit to society, where you have a firm that's providing safe, clean drinking water, and it reduces the risk of unsanitary conditions. It reduces the probability of disease. So that firm is providing that spillover benefit, a positive production externality. And as that wastewater is exiting households in terms of the water that you flush down the toilet, the water that goes down the drain from your shower, the water that you use after you cook and clean your dishes from a meal, that wastewater is also managed by the firm. They filter it, they sanitize it, they make it safe again for use. And so the management of wastewater to reduce unsanitary conditions within a village, town, or city, and the provision of drinking water that encourages health are all spillover benefits. So here we have, again, that other dynamic of the water industry of handling the sewage, the domestic sewage, domestic wastewater, all the same thing, and them collecting that water, filtering that water, and then reusing that water so that it's clean, safe for repeated use. This is all explained in great detail in a Freakonomics podcast called Water Everywhere. But have you stopped to think? It really, if you listen to that podcast, it's an excellent example of how the provision of clean water and the provision of handling wastewater is a significant spillover benefit to society, a significant positive production externality that really maintains health and safety and sanitation standards within a village, town, or city. So I will link that in the video notes below so you can listen to that. In the United States Environmental Protection Agency, the EPA, as one of the regulators to ensure that we are receiving safe drinking water. Every country probably has some type of regulator to ensure the health and safety standards of their water supply. So the EPA providing safe water is a partnership that involves the EPA, states, tribes, water systems, and water system operators. The public drinking water system is regulated by the EPA and delegated states and tribes, providing water to about 90% of the United States. Then it goes down to explain that there are over 148,000 public water systems in the U.S., and thus it's something that we may not think about, we might take for granted, but it is a necessity, and it's important that it is clean and safe and managed well in terms of its waste and disposal. So all that's a positive production externality. Here's another article about a year ago. You can think about something like this for an internal assessment about the debate as to whether natural monopolies should be publicly provided by government, should it be a public good, should it be quasi-public, somewhat private, somewhat public, should it be explicitly private. Here in the UK, they have one private company providing water for, it goes down to explain, let's see here, a quarter, 25% of the population, and that it's a natural monopoly, that they're in a position to generate tremendous profit and revenue, but it has been tremendously poorly managed, too much profit driven, not enough investment within the firm to maintain quality of its piping and taking care of its piping system and so forth. So it's really led to almost a disastrous situation. So again, this debate, should it be privately run or publicly run? Privately run, profit-driven? Could we get bad outcomes with that, with more efficiency? It's up to debate. So let's get into our model. All right, so I'm going to have three models here just so we can see these connections. On the paper 1 exam, in the B section, you're applying real-world examples, and you're free to apply as many models as you would like. And you really want to demonstrate your knowledge to the IB evaluator by highlighting how you can connect one model to another model to another model. Here's an example of that. So natural monopoly is a term. Here we have the definition down below. A single firm or monopoly that can produce to meet the needs of all consumers within an industry at a lower long-run average total cost, LRATC, achieved through economies of scale than two or more competing firms. Examples include public utility companies, electric power industry, water services, and telecommunication. In this case, the natural monopoly is the industry. The single firm is equal to being the industry. A single firm exists for the following reasons. Number one, the high barriers to entry, as I mentioned at the beginning of the video, the high startup costs, the high fixed and sunk costs associated with initiating this firm into the market. For example, the cost of all the water piping a water service firm needs to provide for a town or city, extremely expensive to start doing that. Number two, competing firms within the industry would reduce demand and profit for all firms, thus generating losses and market failure as firms shut down and leave the industry. So it makes sense to just have one firm exist so that you don't compete against other firms and you don't face reduced demand, revenue, and profit and potentially operate at losses where all firms shut down and exit and there's no incentive to provide this necessity for society. And number three, it's allocatively inefficient. Doesn't make sense to have multiple firms providing that good or service when it could be provided by one firm. For example, you don't want to have multiple water piping systems running into a single home from several different water companies where one company providing one set of piping into a house is enough. We don't need to waste more piping resources by providing multiple piping systems from several different firms. Okay? So graph A, natural monopoly providing a public good. This is the market for water and wastewater management. So we're going to graph this as a monopoly model. And so we got to remember, let's go ahead and label. We're going to label on the y-axis price, cost, and revenue. On the x-axis, we're measuring the quantity. And we're going to draw our monopoly model to illustrate a natural monopoly. It's a monopoly model. So we have our supply curve. Goes down and then up due to the law of diminishing marginal returns. Supply is equal to the marginal costs of production. It's going to intersect the average total cost curve. Oops. Don't need that. At its lowest point. So where the supply curve intersects ATC, that is the lowest point. So that is productive efficiency, minimum average total cost. So I would recommend that you draw the ATC and the supply curve first. And then we can get into our demand curve. And you can choose a point maybe here, and then from that point we'll have a relatively inelastic demand curve. I'm going to have that point above minimum ATC. I'm going to label that demand is equal to marginal benefit, which is equal to average revenue. And then I'm going to have the marginal revenue curve split off and go below the x-axis, because where MR equals 0, that's where revenue is maximized. And I'll have a link to that video in the video notes below. I'll also put in the video notes below an explanation of as to why AR is greater than MR for a firm that does not price discriminate. Okay, so here we have our demand, our revenue curves, our cost curves, and now we're going to assume profit maximization. And so we're going to remember that profit maximization is a rule, and the symbol pi represents profit in economics. It occurs where the marginal revenue equals the marginal cost. So we're going to look for that point, and that's existing at this point here, where MR equals MC. The firm is going to produce up to that point. They're going to produce along their supply curve and stop where MR equals MC, and they're going to set their output at that point. Okay, so here we have quantity at profit max, and they're going to then price according to their demand curve. This is what people are willing and able to pay. So that sets price. And we're going to remember that price is equal to average revenue. And then we'll also have our costs of production on average, where the ATC curve at the quantity of profit max. We're going to mark that point. That's the cost per unit. That's equal to ATC. Okay, so average revenue is greater than average total cost. So there we see supernormal profit, the abnormal profit generated by the firm. So I'll label that pi for the abnormal profit generated by the firm. We can also see that in theory it's allocatively inefficient, since marginal benefit is greater than marginal cost. So I can label that. So I should be able to identify that, highlight that as an evaluative point. Monopolies under allocate. They provide less than what's desired by society. Fine. So here we have our natural monopoly. We're using a model, a monopoly model to illustrate a natural monopoly, that single firm providing for society in terms of providing water and waste management. And what's important here is the supernormal profit. How can the firm use that supernormal profit? That supernormal profit can be used by the firm to achieve economies of scale. So I can connect this to graph B, economies of scale achieved by the natural monopoly providing water and wastewater management to society. So here I'm going to illustrate that. So here we got on the y-axis costs, and on the x-axis we're measuring quantity. And I'm going to draw an LRATC curve. So it's going to come down. Maybe this will be better if I just drew it. Okay, so LRATC starts to go down. Then it reaches the minimum efficiency scale, and then it starts to go up. That's the diseconomies of scale. Okay. I'm going to just try to clean that up here. Draw it with a steadier hand. Okay, so that would be sufficient. And I'm going to label this long run average total cost. Okay, here I have economies of scale and then diseconomies of scale. And all I need to do is just illustrate 2 points. So here we have costs at point A, and then the natural monopoly over time achieving lower costs on average at point B. So here we can have cost 1, the initial cost, the initial volume of output, very low, and then costs going down as the firm achieves economies of scale. and greater volume of output. So here we're going from Q1 to Q2, and costs are falling from C1 to C2. So this is an evaluative point, a benefit of monopoly. They can take their supernova profit and invest in research and development. That's another video. I talked about Google doing that. Another benefit of a monopoly is they can take their supernova profit and achieve economies of scale. They can take that profit and spend on expanding the size of their firm, expanding on investing on more capital resources, their capacity to produce. That would cause their supply curve to shift out. Average total cost would also shift down, and you'd be moving from point A to point B. So that would be another talking point in your evaluation. Natural monopolies are able to achieve lower costs on average and greater output to meet the needs and wants of society, as opposed to a new firm. A new firm could be operating at point A. A new firm comes into the industry, higher startup costs at C1, lower output at Q1. They're competing against the natural monopoly that has the economies of scale, lower costs, greater quantity. We're better off with the natural monopoly operating at point B. So that could be another talking point in your evaluation. Okay? Next, now let's connect it to how a natural monopoly providing water, wastewater management is a positive production externality. So we can connect that to graph C. So here we're going to illustrate that we're measuring price, just to keep it simple, on the y-axis, and again, quantity on the x-axis. And the first thing I would do is draw your supply curve. And this is the private sector. So we have supply is equal to the marginal private costs. Then we have the domestic private consumption. Here's our demand curve. D1 equal to marginal private benefit. And I would always draw that first for an externality model. Then we illustrate the free market price and the free market quantity. And we'll use M for market. So we have price in the free, M for market, quantity in the free, M for market. Now we're going to remember that this is positive production. Production is our supply curve. Positive means we want more of it. So I'm going to draw my second supply curve to illustrate positive production. Here we have S2 equals marginal social cost, and on the consumption side, marginal private benefit is equal to marginal social benefit. So I'm almost done drawing this model. Then I'll show the optimal price and the optimal quantity. P-opt, Q-opt. And then I can also highlight how at QM, in the free market, the marginal social benefit is greater than the marginal social cost. And if we can get more output, there we can get marginal social cost equal to marginal social benefit, and we're meeting the needs and wants of society. Prior to that, we have, again, that welfare loss here. All right, and the spillover benefits from a firm providing safe, clean water and also managing the disposal of our sewage waste and unsanitary water that comes out of our household. So a great way to link natural monopoly, economies of scale, positive production. Graph C, just to elaborate a little bit more on this. So here we have in the free market, we have the supply by a private firm providing water and wastewater management. Supply equals S1 equals marginal private cost. The demand is equal to our marginal private benefit, equal to our marginal social benefit. And we see that where S1 equals D1, it provides a free market price at PM, a free market quantity at QM. But we notice that at QM, there's an underallocation of resources. And at QM, the marginal social benefit is greater than marginal social cost. The social benefit of providing safe, clean water and managing the wastewater that comes out of our household, it spills over positively to society. We want more firms or we want more of a firm's ability to provide that service to society because of all the spillover health benefits of having a sanitary water system and disposal system in society. So where S2 equals D1, it shows that social optimum. Society would like more water being provided, where S2, marginal social cost, equals marginal social benefit, providing a lower and optimal price and greater output, which is socially desirable. So we can see that as the monopoly uses their supernova profit to achieve economies of scale and they're able to lower costs and increase output, that's having the effect of achieving positive production externalities and taking us to the social optimum equilibrium. So that economies of scale achieves supply shifting out, S1, S2, it reduces price and costs on average for the household and increases output for society. Okay? And so that was the goal of this video, how we can connect these models, how we can discuss this in a paper 1 part B section or in our evaluation on a paper 2. And that's it. If you have any questions, feel free to comment those questions below and don't forget to subscribe and to like. Thank you so much.